let's talk about reduce. So as you know, reduce is one of my favorite methods in JavaScript because it is very, 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 very powerful. So with reduce, we got the freedom of running any operation about JavaScript. So reduce is equivalent to find, filter, map, even sort. So reduce is a low level method in JavaScript that can be very useful whenever you need to establish some sort of deeper control in your business logic, in your algorithms. So the way reduce works is, let's create a function sum. Function sum receives a list of numbers. Let me call it actually numbers. And then with reduce, we can easily add all these numbers by typing numbers.reduce. So first of all, we got what we call the accumulator. I've never been a big fan of that name. I'll rename it in a minute, but just for educational purposes, let me call it ACC, stands for accumulator. And then the second argument is going to be the each individual number on the array. So I'm going to call it number. Yep. Cool. So now the only thing I need to do is to decide what the next accumulator will be. So in my particular case, I'm going to add all the numbers. I will explain all these details in a minute. I'm just trying to present the algorithm. Then we also need to define the initial value of the accumulator, which I will explain in a minute. All right. So first of all, I wanted to present you the big picture of the algorithm, and now we can go one by one, explaining every single component here. So if I call it with 1, 2, 3, the way this will work is numbers is an array, 1, 2, 3. So the accumulator represents what the algorithm returned on the previous iteration. So if on iteration I we return in number 47, on iteration I plus 1, the accumulator will be 47. But what happened on iteration 0? On the very first time we come across this algorithm, what's the previous iteration? There is nothing, right? On the first one, there is nothing before the first one. That's why we can set up this argument here with the default value of the accumulator. So by default, the accumulator will be 0, and the number will iterate over each individual element of the array. Yeah. So the first number will be 1, the second number will be 2, and the third number will be 3. Yeah. So on the first iteration, we are gonna add whatever the accumulator is, 0, plus the first number, 1. And that will be passed to the next iteration. On the next iteration, the accumulator will be 1 plus whatever the current number is, which is 2, and that will return 3. And on the last iteration, the accumulator will be 3, because that's what we got, that's the basket. Yeah, we're filling the basket when you go to Tesco to buy artichoke. And then we got 3 plus the current number, which is 6. So first of all, let's actually see if it works. And then I'm gonna create a table with all the steps, and we're gonna deal with that all together. So let's run it, and then I'll be with you in a second. Let's see if it works. That should return 6. Actually, sorry, I forgot to add a console log, right? Remember, without any console log, that's not gonna output anything. So if I put the console log, here we go, it returns 6. So now, give me a second. Yeah, so I'm gonna create the table with the steps. So on iteration number 1, I got a question for Max. So Max, can you tell me in iteration number 1, what's the value of the accumulator? It's 0, that's correct. Why 0? That's correct. Yeah, that's correct. So on the first iteration, there is nothing else before. Yeah, so that's the default value, 0. So question for Maxim. can you tell me what's the value associated to the first number? That's correct, because 1 is the first number of the array. Yeah? And then I got a question for Lauren. What are we returning on the first iteration? That's correct, 1, because we return the accumulator, whatever the accumulator is, which is 0, plus the current number, which is 1. So we return 1. That's correct, Lauren. And now, question for Elena. Iteration number 2. What's the accumulator? It is 1. That's correct. That's correct, because that's what we pass on the previous iteration. So what's the next number, Vicky? Hello, Vicky? I think we've lost Vicky. All right. So, Vicky? Y2? Yeah, that's correct. We're on the second iteration, number 2. That's correct, Vicky. Rafa, I'm not sure if you're around. If you're around, can you tell us what this algorithm returns on the second iteration? All right, so I think Rafa is typing something. Oh yeah, it's 3. That's correct. Yeah, Rafa is right. It returns 3 because we return whatever the accumulator was, 1 plus the current number, which is 2, so we return 3. And then I got a question for Elijah. Can you tell me, Elijah, what's the value of the accumulator on iteration number 3? 2. Why 2? Do you agree on that, guys? Is it 2 or not? No. Aaron? Why not, Aaron? That's correct. So, Elijah, remember, the accumulator, it's always whatever we return on the previous iteration. So, if on iteration number 2 we return 3, on iteration number 3, that will be 3. Yeah. If on iteration number 2 we return 333, on iteration number 3 it will be, yeah. So the output on each iteration becomes the input on the next one. This is like a chain. Yeah, exactly. All right, cool. Thank you, Aaron. And then Lorraine, not sure if you're around. Are you around, Lorraine? I'll take that as a no. So I'll jump to Max. What's the last number, Max? It will be, it's 3. That's correct. It's 3. So then what do we eventually return, Maxim? 6. That's correct. Yeah, that's correct. And that's pretty much it, because what happened on iteration number 4, Lauren? So there is no iteration number 4, right? That was a trap. Yeah. So there are only 3 iterations. Guys, I strongly recommend you to write that table until you got a really, really good understanding about how to use reduce. Yeah. So a couple of things. So first of all, I'm not a big fan of calling it accumulator because it tells me nothing about the semantics. So accumulator represents the technical description of the variable, which is fine. However, remember, guys, we shouldn't call for, well, obviously we call for machines, but we shouldn't underestimate how important humans are in this story, right? So we should definitely provide a meaningful variable name for the accumulator. So can anyone offer a decent name for that variable? Total. I like that, total. Yes, total, because that's what we're doing, right? We're calculating the total. Cool. Let's talk about breakpoints. Lines number 2, 3, and 7. So who wants to give it a go? So is that Vicky? 7. What do you think, guys? Is Vicky right or wrong? Brilliant, 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 brilliant. Awesome, awesome. Guys, if you check the first workshop where we introduced breakpoints, it was a big disaster, yeah? Your solutions was breakpoints were 2, 2, 4, even though there is no breakpoint number 4, and 7, right? So great, great, great. That means a lot to me, guys, that you are able to identify the sequence of actions. Cool. Actually, let's just run it just to make sure that we are right. Yeah. So very, very healthy exercise, guys, to use breakpoints to really get a partial view about what's going on each step of the journey. So, for instance, look, 7, then 2, and now we're going to stop on line number 3 times. Actually, I removed the metrics. I should have keep it there, but it's too late. But you see the first value of the accumulator is 0. The first number is 1. If I run it again, here you go. Now the total is 1. Number is 2. If I run it again, total will be 3. And number will be 3. And then that's it. Then we output the eventual result. Yeah? Breakpoints are your friend. Any questions? Are you sure? Yeah, we'll present a slightly more complicated exercise later on. Nice, cool, thank you. What happens if I get rid of the default value of the accumulator? First of all, will it work? Will it report the appropriate outcome, which is number 6 or not? All right, so then let's build then matrix again, right? Iteration 1, and then we got total, and then we got the number, and then we got the return. Yeah. So let's build up the table again. So I would like to start with sometimes I'm a bit slow talking because I'm giving you some points that you deserve. So let me start with Elena. So what's the first total, Elena? Y1. That's correct. That's correct. That's correct. That's correct. That's absolutely right. Yeah, it takes the first element. So that's correct. So now then the question is, what's the first number question for Vicky? Y2. That's correct. That's correct. Because we didn't initialize the accumulator, the original value of the accumulator is the first value, and so the first value of the number is the second value. So what do we return? Rafa, if you're around, you can share what are we returning on the first iteration. It says 3. All right, so he's right. Thank you, Vicky. And now the question is, what happened on iteration number 2? Question for Elijah. So, yeah, that's correct, Elijah. You see, that's correct, because as we return 3 on the first iteration, it becomes 3 on the second iteration. And now, what's the next number question for Aaron? It's 3, that's correct. So what do we return, Max? It will return 6, that's correct. So then, Maxim, what happened on iteration number 3? There is no iteration 3, right? So that's it. That's what we return 6. So that it works, guys. It works. But let's talk about breakpoints. What's the execution order? This time, breakpoints on line number 2, 3, and 14. Anyone apart from Vicky? So Max said 14, 2, 3, 3. What do you think? Yeah. So you. Can you? Oh, wait. Oh, okay. Cool. Yeah, sorry, guys. Cool, brilliant, nice one. Yeah, so you'll agree with Max, right? And he's actually right. So can you see the difference? We are saving one iteration. So if we run it, actually, I didn't stop on the breakpoint. So let me run the algorithm in debug mode. You see, we'll stop on line number 9 first. Here we go. And then line number 2, and then line number 3. And total will be 1, and number will be 2. It will stop again on line number 3. Total will be 3, and number will be 3. And that's it. If I play again, it won't stop again. Yeah, and that's it. And it will output 6. So, hey, it's pretty much the same thing, but we are saving one iteration. So in this particular case, it is safe to get rid of the default value. It simplifies things a bit. It saves one iteration. So technically speaking, we're saving one loop, one iteration in the loop. Yeah. It's probably not a big deal. The difference between running a loop 2 times or 3 times is not going to save the world. But technically speaking, it's better to run loops twice than 3 times, right? But then there is a question, and that question will happen tomorrow on the board challenge review. And the question is, can we always get rid of the default value? Yes or no? So that's a question for tomorrow. Rest assured, I'm going to ask you that question. If we can always get rid of the default value. All right, so there are other usages of reduce. I'm going to present you a slightly more complicated exercise. Before the end of the bootcamp, we're gonna run another workshop about reduce in the context of recursion. Recursion is a very powerful pattern in software programming, so I will talk about that next month. Actually, guys, that one of the things that we expect from you to be certified by Codery is to run a workshop. So we are gonna present you a list of topics. You can either pick one topic out of that list, or you can, get something else that you want to talk about. That's absolutely fine. But one of the candidates, it's always recursion, because I think it's a very important topic. More on that on Slack later. So for now, let's build a slightly more complex exercise. As I told you before, reduce can easily replace other JavaScript methods like find, filter, whatever. So let's try to do something. I'm going to create a function that receives. Let me create a list of cities. So let's cities. I'm just thinking in real time what to do, right? So name, Vienna, population. I don't know. So we can express that in millions, for instance. Yeah, I'm just making that up, so I have no idea how many people live in Vienna. But you know what I'm trying to do, right? So I got Vienna, I got Manchester, I got Valencia, and I got finally, I don't know, Paris. All right, something like that. So now imagine that I want to find the cities with a population above a given threshold. So for instance, if I call find cities with mean population, so I'm going to pass the list of cities as the first argument, and now as the second argument, I'm going to pass the threshold. So for instance, I want to find all the cities which population is above 1.2 million. Yeah, as an example. So, how would you do that, naturally speaking? Filter, yeah, I agree on that. Filter sounds good to me. So, mean population. All right, so then you tell me, how can you? All right, so Elena, do you want to do it? Yeah, with filter. Yeah, with filter. Yeah. 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 Something like that, right? And that's. What do you think, guys? Will that work? All right, let's run it. Let's run it. That's correct, Elena. You see, that's correct. Brilliant. So that works as expected. But now, what if in reality I don't care about the whole object? I don't care about the array of objects. What I care is about the list of city names. So I just care about Vienna, Paris. Dot map. That's correct. Yeah, definitely, definitely. So I can do dot map, and then what? Lauren. City.name. That's correct. We can do something like that. And semicolon. Correct. So if we run it, that will return just the array of cities of the city names. Yeah, and that's fine. Hey, listen, that's absolutely fine. What I want to present you is how can we build the same problem using reduce. Yeah, you may be thinking, but what's the point if map and filter work fine? What's the point of using reduce? We'll see that in a minute. I'm going to leave that there for reference purposes, and I'm going to solve the same problem using reduce, and then we'll see similarities and differences. So with reduce, what we will do is return cities dot reduce cities city arrow function, and now I'm gonna do something. So my accumulator is gonna be by default. Is it gonna be 0? No, it's gonna be an empty array. Yeah, because I want to build a list of cities. Yeah, so I need an empty array as the default value. Yeah, by default I got an empty list of cities. And now what I can do is if city dot population is greater or equal to mean population, so the condition is obviously the same, then cities dot push city dot name. And then remember, and this is where people gets confused often, return cities. You always need to return the accumulator. If you don't return the accumulator to the next iteration, it will become undefined. And then you know, nothing else will work from then on. And that's the way you can build the same algorithm. Yeah, let's see if it works, first of all. You see, it generates the same result. And now let's talk about differences. So using filter and map, that's great. I find it very readable, step by step. However, can you tell me how many times are we actually, no, I'm not going to add breakpoints, but can you tell me how many times will that highlighted piece of code run? So that callback function? 4 times, correct? 4 times. And what about map? How many times map will run? 2 times. That's correct. So in total, we need 6 iterations. Yeah? 4 plus 2. What about reduce? How many iterations do we need here? Just 4. That's correct. So the beautifulness about reduce is that we can combine in parallel all the find versus filter versus map, blah, 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 blah. Yeah? So technically speaking, with reduce, we can build more efficient algorithms. Because in one single looping operation, reduce, we have a lot of freedom to do whatever we want to do. You cannot do that with just filter, because filter will return the whole object. So if you want to transform that object by just keeping the name, you need to iterate again. Okay? So reduce gives you, first of all, performance, and then gives you a lot of freedom. Gives you a lot of freedom. You can do whatever you want. Any questions? Yep. Yep. Yep, that's correct. It could be anything. Yep, that's correct, Vicky. And actually, I'm going to present the last example in a minute, talking about something different, just to prove that how flexible reduce is. Question for you, and that's expected, but that doesn't mean it's easy to answer. Look, breakpoints, line number 4, 6, and 18. Who wants some sexy points in the challenge? Aaron, go for it. How many times? 4. 3 4s, and then 6. All right. All right. I think. All right. Thank you, Aaron. Okay. Do you agree? Disagree? No 3. So all right. Who else? One more 4. So 4 times 4. All right. Who else, guys? Max? 18, 4, 4, 6. All right. Who else? Vicky? Or Vicky or Maxim? All right. So essentially, you agree with Aaron. Sorry, 3 4s. All right, sorry. Okay. Who else? Elena? 6? 4 6. Sorry, 4 6. How many times? How many times 4 6? And 4 again. Remove the last 4. Okay, cool. I think someone is typing. Can anyone tell me? Probably it's Rafa. Can you tell me what? All right. So can. Sorry. So Rafa agrees with Max and Lauren. Okay, cool. Interesting. Thank you, Rafa. Anyone else wants to participate? Guys, you see how gentleman, how British I am now to telling you how wrong you are. If I were German, I'll tell you, you are wrong. You are fired. Right? That's not correct. You are massively wrong. You are massively wrong. That means this is a good exercise, right? Because then you learn something. Yeah, Elia, of course. I was waiting for you actually. 18.6. Okay. Right, that doesn't change my idea about how wrong you are all. So the thing is, you are all, no, it's not that you are all wrong. You are all massively, with capitals M-A-S-S, massively wrong. You're all massively wrong. Yeah, the thing is, you're not even, no one is actually not even close. So, let me, I'll tell you something. I need to think about what's the right answer, but I know you are wrong without even knowing the right answer. So, okay, at least 18 first, fine. Then I'll tell you something. Then it will be 4, then it will be 6, then it will be 6, then it will be, well, wait a minute, it will be 6 again, then it will be 4, then it will be 6. Which has nothing to do with what many of you have said. Why? Look. Well, look. So, first things first, we call the function, and then the thing is, we run the first iteration with the city. The first city is Vienna. Yeah. So then we got the condition: is the population of Vienna about the threshold? Yes. So we're gonna add Vienna to the list of cities. So that's why the first stop will be line number 4. It cannot be line number 6 by the first time, Elijah, because the first city in the list satisfies the condition. So we stop on line number 4 by the first time. And then, well, we return it. So we are passing, after the first iteration, cities will be an array of one element, one string, Vienna. So we stop on iteration number 2, where the city is Manchester. Is the population of Manchester above the threshold? No. So that line number 4 is not going to run, guys. That's not going to run. So, however, we will continue running the algorithm, and we will keep cities, will remain one element array. Yeah? Cities will remain an array of Vienna. So to iteration number 3, cities will be an array of one element. So iteration number 3, city is Valencia, which you can visit from the 1st of July. You are all invited. So is Valencia above the given threshold? No. So once again, it's not gonna stop on line number 4, but it will jump to line number 6 again. How many times I wrote 6? Sorry, no, that's correct. So yeah, that's correct, guys, because this 4 and 6 belongs to Vienna, the next 6 belongs to Manchester, the following 6 belongs to Valencia, and then we end up on the last iteration, which is Paris. Is Paris above blah blah blah? Yes. So we stop again by the second time, you see, by the second time. And that explains why the array has 2 elements, guys. You already knew the array has 2 elements. So if the array has 2 elements, definitely we need to stop on line number 4 twice. That's why it doesn't make sense to think that we're stopping 47 times on line number 4, as you said, right? So we stop on line number 4 twice, and of course, eventually we'll return it. That's why we will finally stop on line number 6. That should be the correct order. Actually, let's run it just to prove the theory. So, what is my breakpoint? Here we go, line number 18. 4, you see. Now we'll stop on line number 6. Now we'll stop on line number 6 again, you see, with Manchester. Sorry, where I am? Hello, VS Code. Here we go, Manchester. And then we'll stop again on line number 6 with third city, Valencia. Yeah, and now, because we're gonna deal with Paris, we'll stop again on line number 4. Here you go, you see, city is Paris. And then we'll eventually, on the last iteration, return an array with 2 elements, Vienna and Paris. Yeah, that's what I originally proposed. Questions? No? All right. So let's play a last example. Let's talk about objects. I'm just making the example up, so I'm not sure if that will make sense. So if I got an object called user, first name Peter, and last name Smith, and then age 21, and what else? Location, leads, and then we want to run some operations like, I don't know, I just wanna keep the I don't know. I just want to have the object, another object, yes, keeping the properties. That's a bit weird, but I also want to return an object with properties start by F or A. Yeah, you see. So eventually, I want to get another object with correct first name Peter and age 21. Yeah, another example from a semantics point of view can be definitely improved, but you know, at least I hope you get the point of what I'm trying to build. Yeah, I'm trying to return a new object with different properties. So then we can definitely do find user or find user props. I don't know. Yeah. So we pass the user, and then yeah, I guess we could use filter, right? I guess. Can we use filter? I don't know. Let's play with filter first. So to play with filter, because that's an object, we first of all need to access the keys. Yeah. So do you know how to access the keys dynamically of the object? Correct. Object.keys, and then we pass the user. So then we will have filter maybe, and then you see, I'm trying to present a problem that cannot be easily solved using filter. Because if I use filter, then what? All right, so I can see key of 0 equal A or F, whatever, or key of 0 equal, let's do it alphabetically, even though that's not actually relevant. Yeah. All right, and that will return an array with all the keys that are first name and the age, right? That's what that algorithm will return. All right, but then what? I mean, I cannot solve the problem that easily, right? Because I need to then probably save that into a variable. So let keys, something like that. No, if I return the keys, I will return an array. And I don't want to return an array. I want to return an object. So, you know, that's quite difficult, actually. That's quite difficult, because then I will have to create probably a new object called new user, which is an empty object. And then I will have to iterate over the array of keys, keys.forEach. So for each key, what I will do is something like user of key, new user of key equals user of key. And eventually, I will return new user, yeah? Which is a bit weird. It's very weird. But first of all, let's see if that works. You see, that works. But do you see the complexity of this algorithm, right? I have to create a variable to get the keys, and then I have to iterate over this array, and then dynamically I'm building a new object just with the keys I'm looking for. Yeah? So when talking about objects, everything gets more complicated, because arrays, all right, we can easily chain array operations, map, find, filter, sort, whatever. But with objects, it's not that simple. It's not that easy. Yeah. So fine, you can do that. I'm not against that. You can do that. However, you know, that's a bit complicated. So let me show you how to solve the problem easily with reduce. I'm gonna share that with you on Slack. What is Slack? All right, so I'll share that later on. So let's solve the problem using reduce. With reduce, I don't need to create any variables. I can start typing return. You know, guys, if you're in a job interview and they present you an algorithm and you need to write a function, and the first thing you type is return, you are proving the size of your balls, essentially. You are telling the employer that you got the situation under control. Because if you type return, that means you know what you need to do. Otherwise, you'll start messing around. Let variable x and then let y. You'll start messing around creating weird variables as an intermediate steps. But if you type return, you really know what to do, right? So look, return object.keys user dot reduce. So I'm gonna create a variable called new user and then key. The default value will be an empty object. Let me. Yeah, sorry, I didn't open. Good, thank you, Vicky. Yeah. So my default value is going to be an empty object because I want to build a new object, yes, with the keys. And now, look, the same thing. If key 0, the condition is the same, right? Equals a, or key of 0 equal f, then what? Well, then new user of key equals user key. Yeah, I'm building the object. Do we need to return, do we need to do anything else? Correct, Aaron. Return new user. That's correct, Aaron. Yeah, because we want to pass it to the next iteration. So that algorithm is running the same operation as the previous one. But I believe it is more readable. It is better. I have to loop less times. I have to create less variables. I don't know. So the more complicated the algorithm is, the better reduce will work, or the more the easier it will be to see the advantages of using reduce. So you see it returns the same output. So let's talk about breakpoints just to see if you actually got it. So, all right, so I got a few breakpoints there. And who wants to give it a go? Okay, Aaron? Yeah. Cool. Thank you, Aaron. Anyone else? Cool. Guys, if you remember Quake game in the 90s, that was a headshot. Yeah, when you kill someone by shooting in the head. Aaron, because you like gaming, so Aaron did a headshot because he got the right answer straight away. Yeah, that's correct. That's correct. That's correct. We start on 17. We go to line number 4. So the first key is the first name. Yeah. So does the first name satisfies the condition? Yeah. So we add it. We add that that property to the new user. Yeah. And then of course we return it. So on the second iteration, last name. Does the last name satisfy the condition? No. So we jump, but we still return it. So that's why 17, 4, 6. So 4 and 6 belongs to the first name. The second 6 belongs to the last name. And then we move to the 8. Does the 8 satisfy the condition? Yeah. So we go inside. 4, we return it. 6, and then eventually we check the last name. Does the last name, sorry, not the last name, the location. Does the location satisfy the condition? No. So we never stop here in that iteration. Number 4, we just return it. That's the last 6. Let's run it just to prove the theory. So 17, 4, now it will be 6. Now it will be 6 because of the last name. You see, guys, on the left-hand side of my screen, you can get the key in each iteration in real time. And then we'll stop on line number 4 because we got 8. And then we are going to return this accumulator. And then finally, we'll move to the location, which doesn't stop on line number 4. So we'll just return it. So Aaron was essentially right. Any questions? All right, so if there are no questions, that means you are going to tell me, as the last activity of this workshop, you are going to tell me all the variables, right? So let me prepare it a bit so you can think about that in the meantime. So let me start from Max. What's the first value of the new user? First name? What do you think, guys? That's correct, Lauren. It's not first name. It's an empty object because it's the first iteration, so we pick the default value. Yeah? So that's correct, Lauren. Elena, what's the first key? First name. That's correct. And what do we return on the first iteration question for Vicky? Peter as a string. What do you think, guys? That's correct, Aaron. Because we started to build the user object, we're going to return first name Peter. Yeah? Cool. Great. So then question, yeah, I'm gonna skip Rafa, not because of anything in particular, but I cannot read his answer, so it's a bit difficult to me how he doesn't mind. Elijah, can you tell me on iteration number 2, what's the value of the new user variable? Undefined. That was brave. Because if it was undefined, nothing else will work later on. Yeah? So it's not undefined. It's not undefined. Can anyone help Elijah? What's the value on the second iteration? That's correct. Elijah, we discussed that before. Remember, whatever we return on iteration I, gets passed as the next one. Correct. Yeah. First name Peter. So what's the key in this occasion, Aaron? What do you think, guys? Is it H or not? That's correct. That's correct. Aaron. Yeah, of course, one or the other, right? Yeah, so Lauren is right. You cannot, guys, you cannot skip iteration. Yeah? So we need to go through every element, and then we'll see what we do on each occasion. All right. So then, question for Max: What do we return at the end of the second iteration? That's correct. That's correct, Max. You see, we are not incrementing, we are not modifying, we are not altering the accumulator because last name doesn't satisfy the condition. So that's correct, Max. And now, Maxim, can you tell me what's the new user on iteration number 3? I think we've lost Maxim. All right, so cannot hear Maxim, so let me jump to Lauren. Can you tell me, Lauren, what's the value of the new user in the third iteration? That's correct. You see, guys, the rule is the same. Whatever we return is the next accumulator. Whatever we return becomes the next accumulator. It's the same rule all the time. So now, question for Elena. What is, Elena, the next key? Elena? I think we've lost Elena. People is dying, guys. Don't know what's going on. Yeah, we can hear you. That's correct. Yeah. Yeah, it's the age. That's correct. That's correct, Elena. And now, Vicky, what do we return at the end of iteration number 3? First name Peter, and we can. Sorry, Elena, the connection is quite bad, I believe. Yeah, there are some issues out there. 21 level, right? Cool, that's correct, Vicky. So now iteration number 4. Question for Elijah. What's the new user value? That's correct. You see, Elijah is the same mechanism again, and again. So that's correct, Elijah. What's the next, Aaron, what's the next key? Location, that's correct. So what do we return? Question for Max. That's correct. That's correct. First name Peter, age 21. And then question for, I don't think Maxim can listen to us because of a reason, or maybe he can listen, but we cannot listen to him. So Lauren, what happened on iteration number 5? No iteration number 5. Yeah. Yeah, I don't know why we always end up on Lauren with the same question, but I'm just following an order, guys. I promise. I don't exactly. It's like that's correct. So eventually, yeah. So that's the eventual value that the algorithm returns. Okay, Peter. So that's a good example where the accumulator doesn't necessarily have to change on every iteration. We just change it when we want. Yeah? So sometimes it will be updated, sometimes it will remain as it is. Anything else? Any questions? No? Cool, awesome. I'm gonna share that on the Slack so you can play with that. And once again, make sure you play with it, you paste it into Playground, you change it, all these things will help you to understand the flow. Cool. If you don't have any other questions, guys, that was it from my side. Thank you very much, and we'll see you later.